Greetings everyone. Today we're going to explore graphing equations of parabolas, but two specific things. This video is going to be in focused directrix form, and we're only looking at the origin for our vertex today. So this is intended to be an introduction. Make sure you have the correct note sheets that you need. Let's get started. Alrighty, let's start off talking about a parabola. A parabola is a type of conic in which any point on the parabola is equidistant from the fixed point called the focus. And we're also equidistant from the fixed line called the directrix. So if we were to label, if you take a look at that blue parabola, we're used to that. We're used to having a vertex. But what we're going to work on and what's new in this video is talking about the distance from the vertex to the focus and the distance from the vertex to this new line called the directrix. Now those two distances are going to be equal. So if you know one of them, you'll know the other one. We know from our previous conic videos that finding the distance from the focus to a vertex, we've had formulas to do that, so we're going to see how that plays out today. We know from our work with any parabola ever in the past that we have a line of symmetry that would cut through the vertex. And so why is it important to have this form? Because that idea of having a point that's equidistant to the parabola and then to the directrix is important in the real world. If we're talking about, let me bring up the next slide, satellites. That distance matters because if we're trying to receive and get the best signal possible, we don't want that signal just all over the place, right? Or personally, I can relate to a flash. When that flash shines in, how much flash comes out determines the type of flash I'm going to have, right? The type of light that it's going to be given. So in the real world, anytime you have that sort of bowl shape, which is a parabola, that focus matters. Its distance matters. So in our notes, let's jot down the standard form for a parabola. If you need to pause to do this, please do so. Now, when we're talking about standard form of a parabola, we have one value that's squared. Okay. If the x is squared, then it's like all the parabolas we know, right? If the x squared, it opens up or it opens down like we're used to. If the y was squared, then it would be sideways. And we haven't had sideways parabolas yet. That'll be new. We have this value of 4. Now, I'm not going to get into where that 4 came from, but I do have a link if needed, if it's helpful, if you want to understand it more clearly. P, the P value is going to be so important. If I look at the P value, if I see that I have a positive value, that means it either opens up or opens to the right. If the P value is negative, opens to the left or opens down. That makes sense as far as direction. And the p-value also tells me the number of units from the vertex to the focus. And if I know the distance from the vertex to the focus, then I also know the distance from the vertex to the directrix. Now, of course, it's not going to say 4 times p always. It might say 12. Oh, well then p would be 3. Or it might say 20. Then p would be 5. So you might have to just divide to find that p-value. Now what we're used to, as always, whatever is being added or subtracted to the x and the y is your vertex. So again, here's an image if we talk about when y value is squared. Then we're talking about a parabola that goes to the right or to the left. Again, pause if needed. If it's positive, if the p-value is positive, it goes to the right. If the p-value is negative, it opens to the left. quickly, without jotting this down or anything, let's just quickly review again how that p-value is going to look. So if I'm given this first equation here, I can't just say my p-value is 12. No, I have to think, what is that divided by 4? Right? So the 4 value is part of the problem, which means I have a -3 for my p-value. It's an x squared, which means it's up or down. It's negative, so it's down. The next one, if I divide by 4, that means my p-value is 2. It's the y squared that is, it's the y that's squared, and it's a positive p-value, so that means it opens to the right. Lastly, if I divide by 4, if you divide by 4, you're going to have a fraction? Yes, we can have fractional distances. Let's see, if I divide by 4, I would have 3 halves. That's okay. We can have 3 halves. You could think of it as 1.5 as well. My p-value is positive. My y is squared, so that would mean it opens to the right. I will put this link on Google Classroom, or you can just Google where does that 4 come from. I'm not going to get into it in this video, but just know if you're interested, it's out there. All right, let's jump straight into an example. Remember today, and in this video only, we're specifically looking at the origin. So another way to think of this would be, oops, let me rewrite this just to show you what we're talking about. It'd be like y plus 0 squared. If my formula has a 4, this is like an x plus 0. So 4 times what gets me to 8? 2. So my p-value is 2. The y is squared and the p is positive, so it opens to the right. So I'm at the origin. That's my vertex, today and today only. My p-value is 2, so we're going to jump to 2. 2 is going to be my focus. Therefore, 2 to the left is that directrix. And I know you shouldn't think of it this way, but I kind of think of the directrix as an asymptote, so we draw it dashed. The axis of symmetry. The axis of symmetry is the x-axis, right? The x-axis would cut it in half. So the line y equals 0. Let me actually color that so you know what we mean. Y equals 0, right? So this line in red would cut my parabola in half. Okay. Focal width. Now this isn't something we talked about in the general instruction. So make note here. The focal width is this number, meaning the distance around the focus is 8. So I want that distance to be equal. Therefore, I go 1, 2, 3, 4 to one side of the focus and 4 to the other side of the focus. So do you see between the green dots, I have a distance of 8. Around the focus, I have a distance of 8. Okay. Our focus, I already identified that. That was at 2, 0. The directrix, I drew it as a line, a dashed line. I said kind of think of it as an asymptote. So because we would draw it like a line, we write it as a line. X equals -2. I'm going to draw my parabola. I always forget to do that in my videos. So we want, oh gosh, that's not good. Let me try again. We want a parabola that curves around and goes through that focal width that we created. Domain and range, nothing special. We exist from an x value of 0 to infinity, and our range is from -infinity to +infinity. Those are the same rules as always. Alrighty, let's take a look at a second example. Now I'm adding this example in later, so I apologize if the video shows up a little choppy, but let's take a look. First of all, I want to acknowledge that x squared is isolated on one side, and I'm just going to take a moment to rewrite to acknowledge what my p-value is if I divide out that 4. And so that would get me a -5. So let's fill in some details. P-value is the distance, so my physical distance is 5, no negatives. Opens. X squared is what we are familiar with. That means up or down. Since it's a negative, that acknowledges down. Focal width. Focal width is the number in front. Originally, it's a physical distance, so it's the positive of that value. Vertex, today and today only, is at 0, 0. If you need to see translated or different locations, please see my other video. I'm going to start with this information just to get started. So 0, 0. We're opening down, and so I'm going to draw 1, 2, 3, 4, 5 spaces down. That becomes my focus. So my focus is at 0, negative 5. My directrix would be 5 in the other direction. 1, 2, 3, 4, 5 north. Directrix is, we acknowledge it with a dashed line. Think of it like a border, a marking that we don't cross. My directrix is a line, so it's written as such. So it's slicing the y-axis at 5. Axis of symmetry. Axis of symmetry is what slices my parabola in half. And it'll always be the opposite value of the directrix, meaning if my directrix is y equals, my axis of symmetry is x equals, and today only, it will be 0. Let's draw my parabola here. We need a shape to go off of. And so my focal width is 20. So around the focus, I need 20 units split in half. The focus in the middle, I should say. Just fits. You're going to have a lot of graphs that don't fit. So if you have to go off your graph, don't be surprised. But now I can draw this fairly wide, parabola. Hopefully you draw better than I do. All right, let's talk about domain and range. Forever left, forever right, because it is up and down. My range, least to greatest. So it goes to negative infinity, but it only goes as high as 0, which makes sense because it's the number of my vertex, and it's always a bracket. So remember, parabolas always have 3 infinities and 1 bracket. Now, I wanted to just quickly show you, these are not very likely easy to type into a graphing calculator unless you have the program. So if you're working and figuring it out on homework and on your own, feel free to use Desmos as a resource. We can type in any equation we want into Desmos, and I can check. So for example, I typed in 2, 0 to see if it made sense for my focus, which it does, and I labeled it focus. And then if my focal width is 8, then I should have dots with a width of 8. So from 4 to negative 4 was my width of 8. And they land on my parabola, so I know that that width was correct. I also created my directrix, x equals negative 2. So that allows me to see that everything's correct and good to go. So utilize this resource. Now, because that is the only example in your notes, I am going to go through just some extras. Again, jot these down if you feel like you need them, or just follow through and watch. But I specifically chose some equations to clarify a few things. So, for example, on this one, notice how the x squared is on the right. If you like everything to be written the same way, then you can certainly put that x squared on the left. Now, I'm going to put a plus 0 to remind myself that my vertex is going to be at 0. I have a value of 4 in my formula. There's nothing being added or subtracted to the y. If I go from a 4 to a negative 4, then my p-value is negative 1. Now, it's x squared. X squared is like a regular old parabola, right? That's what we're used to. So that would be an up or a down. Because the p-value is negative, it opens down. I'm going to jump down to my vertex of 0, 0. My focus, if my p-value is 1, my focus is 1 unit in each direction. Let me use some colors here. We said we're opening down. So that means I'm down 1 unit at 0, negative 1. Does that make sense? Therefore, my directrix would be equidistant on the other side. It's like an asymptote in that it's a dashed line and we never cross it. So my directrix, I like to draw it first, is y equals 1. It's a line. Axis of symmetry, if I was to cut my parabola in half, it would be x equals 0 because it would be the y-axis. My focal width. Okay, let's look at our original number. Our original number was 4. So my focal width is 4. So from the focus, I want equidistant on either side, but a total distance of 4. Now I can draw my parabola through my vertex, through that focal width. Kind of shows me, because they're close together, it's going to be a little skinnier. That makes sense, because I only have a p-value of 1. My domain is forever left, forever right. My range is from bottom to the top value of 0 with a bracket. Now make note that you're always going to have one, either the domain or range that's infinite, and you're going to have one domain or range that has a bracket. Every parabola is going to have that situation. Let's take a look at this one. Again, I'm choosing this. So if you understand the graphing, just pay attention for one more minute about the example, about the equation. That negative does not stay there. That negative needs to be divided to the other side. So I need to organize this equation. All right, so it's y plus 0 quantity squared. Negative 20. Oh, wait a second. I want to write it with a 4, remember? So how do I get from a 4 to a negative 20, a negative 5, x plus 0. See how I did that? So you need to isolate the squared value. Isolate the squared value. So my p-value is negative 5. The y is squared, so that means left or right. If it's negative, that means it opens left to the negatives, right? So I'm at 0, 0 again today, and today only. My axis of symmetry, if it opens left, would be the x-axis, so that would be y equals 0. My focus, my p-value is 5, right? So I want to go 5 to the left. 1, 2, 3, 4, 5. So my focus is at negative 5, 0. My directrix would be 5 in the other direction. It is a line, a border. Therefore, it is x equals 5. Focal width. Oh my goodness. Check this out. My number is 20. It was 20. The positive and negative doesn't matter. The distance is 20. You might be thinking, how are we going to graph these distances? Well, we can, because from the focus, if I want it to be equal on each side, that actually means 10 in each direction. So if it does go off the graph, account for that, graph accordingly. So that means I have a super wide parabola opening to the left. Well, when you have a larger p-value, you have a wider parabola. My domain is forever left and to the right at 0. Therefore, my range is the negative infinity to infinity. All right, that's our introduction to parabolas in focused directrix form. Make sure, as always, you check out Google Classroom to see what today's task is. Let me know if you have any questions. Seek out other videos or other teachers if needed. And until next time, have a good one.